Bismillahirrahmanirrahim. Assalamu alaikum. Uh, the subject I want to talk about in this video is the key value database. I talked about the key value database in the previous video we had, and I said that the key value database is a database that is based on key values. The data that we have are in the format of key values. Key value, we said it is a more complex data structure compared to arrays. Arrays were a simple data structure which had an index and the value. The index was some numbers, integer numbers, and the values were some value with the same type. All of the values was from the same type. And then we talked about an associative array, which was an array which didn't have any limitations on the indexes and on the values. So the index could be numbers, strings, and anything, and different types of indexes. And for the values, we could have different types of values. We don't need to have the same type of value for all of the data in the associative array. Okay, in the key value database, the key value is something like the associative array, and we said that the key is something we want to it is a reference to a value, and in different databases we have different types of keys, and the value is the object, which is the value we want in the database. The main thing, that's the data. Okay, that's the data we have, and for the same to the keys, the values could have different types: integer, floating point numbers, and different things. In the key value database, we have a concept namespace. The namespace, it has one limitation, that we can't have duplicate key in the namespace. The keys should be unique. Okay, we can't have duplicate keys. So the keys should be unique, and that's the main restriction we have in the key value database. Okay, in this example, you see that we have a database with three namespaces. Okay, bucket 1, bucket 2, bucket 3. These are the three namespaces that we have. And as you see, in each of these namespaces, we don't have duplicate keys. Okay, we don't have duplicate keys here. We don't have duplicate keys here. Okay, we don't have duplicate keys. Now, I said that how we could build the keys for our data. We could build it like this. This is a simple method for building keys for the key value database. We could each of our data, it has an entity name, it has an entity identifier, okay, and an entity attribute. Each of the data that we want to store in the database. Okay, for example, for the customer first name is a data that we want to store in the database. Okay, so we have an entity name which is customer, CUST, customer. The customer has an ID. Okay, for example, here is 12387. That's the ID of the customer. Okay, between these two, I have a colon here. This is the column. the ID, and then a colon, and the name of the attribute, entity attribute. Here, I want to save the customer first name, okay? Okay, for example, the customer has 5 attributes. For each of the attributes, I will have a key, okay? Customer 12387 last name. Customer 12387 address. Okay? The different attributes, each of them has a key for each customer. Now, um, how could we find the data in the key value database? How do we find the data? Okay, as we said, the data is in the format of key values. Okay, we have a key, and then we have, for each key we have a value. How could we define a relationship between the key and the value? Okay, here we use the hash function. We give the key as an input to the hash function, and the hash function gives an output that with that output, the output is the address that we put the value there. Okay, for example, for a customer 19823272737. Okay, that's the key, and then first name. That's the key. Okay, I give this key to the hash function, and the hash function gives me an address. This is the address. Okay, then I store my data in this address. Again, for the different attributes of the customer, we have different keys for each customer. Okay, for each customer, we have different keys for every attribute. And then you see it here: the customer first name, last name, shipping address, shipping city, shipping state, and shipping zip. These are the attributes for the customer. Each of them has a key, and then we give it to the hash function. The hash function gives an address. That's the place. The address is the place which is the value stored. Okay, that's about how to find the values from the keys. Now, one challenge for the hash function is collision. What does collision mean? Collision means that sometimes two different inputs of the hash function, they have the same output. For example, in the subject we are talking about it now, it's about the key value database. I said that we give the key to the hash function, and the hash function gives an address. That's the address where we're going to store the value. Now, sometimes the hash function gives the same address for different inputs. Okay, I give the hash function different inputs, but it gives us the same address. Okay, that's called collision. And for the collision, we have different methods to handle collision. A simple implementation would be to implement a list in each cell of the hash table. Okay. Uh, this could be a simple solution. Okay, look here. For example, these two inputs, customer number 7328 and the attribute last name, customer number 8983 and the full name. Okay, so here you see different customers with different IDs. Here you see only one uh, key value for that. Okay, the two different data, but they have the same key. They have the same hash for the key. We give the key to the hash function. The hash function gives us a value. Sometimes it gives us the same value for different data, like this one here. Okay, now you see this is a solution. Okay, for these keys, this is a solution. Okay, I give a reference to this data here: customer, the customer number, the country, and the attribute. Okay, last name, for example, and the value of the attribute. So this is collision. This is some important challenge for the hash function. Okay, now suppose we have a database which is a relational database. We have a relational database. Okay. Now, how could we convert? How could we convert this relational database to a key value database? Okay, we want to convert it and store the data in uh, the key value database. How could we do this? You see an example again for the customer, or we have some customer data about the customers, and uh, each of the tables in the relational database, each table has some attribute. Okay, and each customer has an ID. So we could convert each of the tables to a group of key values. Okay, this is how we could convert a relational database to key value. So we get each of the tables, we check the attributes, and then we start defining the structures of the key value database. Okay, now the key value database, it has some features. Okay, the key value database, it has some features. There are three main features: simplicity, speed, and scalability. These are the three main features we have for the key value database. Okay, we will talk about these features. The first one is simplicity. The key value database uses a bare minimum data structure, and they have a small set of features. Okay, so uh, the key value database is very simple. If you want to compare this, okay, suppose that we want to write text. Okay, okay, we could use Microsoft Word or we could use Notepad. In Microsoft Word, we have a lot of features. We have um, a lot of uh, different features that we could use for writing and in a text in the computer. But for the in the notepad we could do the same thing. in Notepad we could do the same thing, but we don't have any features in Notepad. Okay, we don't. We have a little number of features. We can only write the text. We could give it the font size. Okay, but we don't have many of the features that we have in the uh, Microsoft Word. Okay, so sometimes we don't need those features. Okay, for example, the relational database, it has many features. For example, the integrity is one of the main features of the relational database. But sometimes we don't need these features, and we want to have a simple design. So key value could help in these situations because in the key value database we don't have many features, uh, uh, and we don't need it. Okay, one of the things that make the key value database simple is that it doesn't have a schema, okay, or schema. As we said, many of the NoSQL databases they don't have a schema, and the key value database is one of them. One of the other simple things in the key value database is that the database are free. The data types are free for the attribute. For example, for each of the data, we could have any different types for the values of the attributes. Okay, for example, the grade, it could be a character, okay, and it could be a number. This is an example of the data types. We said that the data types are free. For example, one of the attributes we have is customer address. Customer address is one of the attributes we have. This customer address, it could be represented in different formats. The first one is one format, the second one is another format, the third one is another format. Okay, all of them are customer address, but we have different formats that we can use. And also, we have some limitations on the size of the values. Okay, for example, the address. What is the size of the address? 50 characters, 100 characters. Okay, we have to define. We have to define this. Uh, uh, this is we don't have to define it. This is something that we have in the database. Okay, for example, in some key value database, maybe the limitation for the value is um, uh, 100 bytes, for example. So we don't have any limitation on the types of data that we store in the attributes. Okay, this was about simplicity. The next feature of the key value database is speed. Speed is very important in the database. One of the things that causes to have a higher speed is the use of RAM in the database. Okay, we could use the RAM memory to help the database. Here, for example, uh, we have a client here. We have some uh, a server here. This client wants to do an operation, for example, a write operation on the database. In this server, we have a cache. Okay, we have a cache. when the client wants to do an operation and the server uh, does the operation in the RAM memory, okay, and it says that the operation has been done very fast because the RAM memory is faster than the disk. Our data is stored on the disk, okay, but we can do this operation in the RAM memory, and then we give an acknowledgement or a verification to the client. We say that this task is done. This task is done. Okay, and then later, uh, later we write the data on the disk. Okay, so uh, we can use the RAM memory to have a faster write operations in the key value database instead of uh, saving the data in the disk. We do the operations in the RAM memory and then we save the result on the disk. That's a method for uh, having faster operations in the key value database. One issue about this method is that sometimes all of the memory is allocated. Okay, all of the memory that we have is allocated. So to continue our operations, we should make some of the memory free some of the memory, okay, so the database could use it. So this is a challenge we have for this method in using RAM for doing fast operations. I said that the client connects to the server and the server does the operation in the RAM memory and then stores it on the disk later. And because the RAM is faster than the disk, so we will have faster operations. Okay. The last subject about the last feature about the key value database is scalability, and scalability is the capability to add or remove servers from a cluster of servers as needed to accommodate the load on the system. Okay, this is the definition of scalability. Scalability means that when, for example, we have an application and different people are working with this application, okay, then we see that the requests on this application is increasing. The requests are increasing, so we need to scale our database. We are having very much operations and we need to scale our database. We talked about scalability in the previous videos in the relational database where we were talking about the uh, uh, problems of the relational database. Here we have a scalability too. As I said before, scalability is an important subject which we have it in different types of databases, and we need it when the number of users and the number of transactions on our application is increasing. Okay, for the scalability, we have different facilities. Okay, we have different facilities in the key value database. One of them is the cluster. Okay, cluster. It is a concept. It is a set of computers that are connected to each other to do something. A set of connected computers that coordinate their operations. Okay, that's the definition of a cluster. A ring. A ring is another definition. A ring is a logical structure of organizing clusters. A ring is a circular pattern, as you see here. It is a circular pattern in which each server is linked to two adjacent servers or instances. Okay, each server is connected to two other servers. One, two. Partition. Partition is a group of servers in a cluster which are assigned a job. In key value database, partition is used to manage subsets of a database. Okay, so partition is a group of servers that want to do a job in the cluster. Cluster is all of the servers we have. Partition is a part of it. For example, in the partition, we may have 50-50 workload. It means that we put 50% of the data on one server and 50% on the other server. And sometimes we do more intelligent methods and we store we store the data on different servers, each with different workloads. Okay, partition key. Partition key is a key used to determine that our data in on which of the partitions. Okay, for example, here we have two partitions. Okay, this is one partition, server 1 and server 2, and this is one partition, server 1, 2, and 3. For example, it says here in this figure, the first letter of the data keys could be used to define the partition key. Okay, you see that, for example, in this server, the keys are starting from A to F and from G to L. In this server, it's from M to R and S to Z. Okay, so we could define the partition key so that we can say that where is our data, on which partition, on which server is our data. Okay, this was some concepts about scalability. Cluster is a group of servers. Ring is a logical structure. Partition is a subgroup of the cluster. And partition key is something we can use to know where is our data. Okay, the next subject in scalability is replication. Okay, again, I talked about replication in the relational database. We said a replication is getting copies of the database, and this replication helps for the read operation. It increases the speed of the read operation. In the key value database, we could have two different uh, replication techniques. The first one is master-slave replication, and the second one is masterless replication. Okay, in the master-slave replication, uh, we have two different nodes and nodes in the cluster. Okay, we have some master nodes and we have some slave nodes. We have two different types of nodes. Before I continue, here we have talked about an example here, and we have said that many applications have many more reads than writes. Read operation, a read operation is usually more than the write operation. Okay, read is usually more. For example, when someone goes to an e-commerce site like Amazon, it first the person search for many different products, and then he selects one, and then he goes to the next steps. So the read operation is usually more. So first we want to scale the read operation using a replication. In the master-slave replication, the master is a server in the cluster that accepts writes and read requests. Okay, you see here the master slave. This is the master, and these are free slaves. The master node, it could do read and write operations. The master node, and the other node, they can all the other nodes. It means these slaves, they can only do read operations. Okay, so we have a server that can do the read and write operations, and then we have some other servers that can only do the read operation. Okay, so this is the master-slave replication. We have a master and we have some slaves. The slaves are doing the read operation, and the master read and write operations. Now, one problem in this structure is that sometimes the master node fails. The master node fails, so we don't have a master. Then we have, for example, here we have free slaves. Okay, what happens if the master fails? Okay, these slaves, they should have talk to each other and have a decision for the master node. So one of these nodes, one of the free nodes, they are selected as the new master node. Are selected as the new master node, and then we continue uh, our operations in the application. So if a master fails, then the slaves should decide who would be the next master. From these free slaves, one of them would be selected. For example, slave 2 is the next master node. The second architecture for the replication in the key value database, it is the masterless replication. Okay, masterless replication. In this type of replication, all of the servers, they can have read and write operations. So, different from the master slave, here we don't have different nodes. all of the nodes are in the same level, and they can do read and write operations in the cluster. For example, in this masterless replication, we could have 4 replicas for each of the servers. We could have four four replicas, so we have 4 copies. As you see here, for example, in this server number 8, okay, it is connected to server number 7, connected to server number 1, and that's it, okay. And also it is connected to another server here, server number 6. So 8 is connected to 3 different uh, excuse me 8 is connected to server 1, server 7, and server 2. Okay, look at the arrows that have that go out from this server. Okay, this is one arrow, this is the second arrow, and this is the third arrow. Okay, this says that for each of the server data we have 4 copies. One of it is on the server itself, and 3 of it is replication. How to store key values in the cluster? How can we store key values in the cluster? Divide the hash value of the key by the number of servers and get the remainder. Okay, what does this mean? For example, if we have 8 servers, like this figure, we have 8 servers, then we want to decide where we should put the data now. We get the hash value of the key of the data, get the hash value, and then we divide the hash value by the number of servers. Okay, the result is when we divide the result of the division, it would be a number. For example, if we have 8 servers, the result of the division, it would be a number between 0 and 7. Okay, if we have 8 servers, the result of the it would be between 0 and 7. So if it is 0, it means server number 1. If it is 1, it is server number 2, and if it is 7, it's server number 8. Okay, that's how we could store the data in the cluster. And the last subject here is compression. Okay, compression is very important in the database. Key value database have many operations in the memory, so they are memory intensive. So we need compression in the key value database. We need compression. There are different methods for compressing the data, and some of these methods, the compressed data is very little and very small, but the algorithm is not very fast. But there are some algorithms for compression. The algorithm is fast, but the data which is being compressed is bigger. So we have to select one of these algorithms for compression. And until now we have all talked about the advantages of the key value database, but what are the limitations? One of the limitations is when we want to search for data, all of the searches, it should be based on keys. All of the operations we have in the key value database, they are based on keys. That's the limitation. Key value database do not support query languages. As we said before, in the relational database, we have a language named SQL that we could use for doing operations. But here in the key value database, we don't have any language. So the programmer has to write what it needs, the developer. The developer has to write the operation it needs. That's the very two important limitations in the key value database. Okay, so I talked about our subject about key value database is finished here. We talked about the key value database, and we said that this database, it has some features, which is simplicity, speed, and scalability. And we said that the key value database, the data is stored in the format of key values. We should define the keys, and we give a method for defining keys in this database. And we talked about why is this database simple, why it is fast, and why uh, it could be scaled. Okay, thank you very much.